Welcome to the problem session here. So we are on the JEE prep, and I've gone back to F equals MA problems. I veered into momentum and then some circular motion, and then I said maybe we need to do a little bit more of these. They look simple, but can be confusing and times challenging. And there may be some techniques you can learn along the way to simplify things, okay? So here is a interesting system. We have these two masses, and then you have, there's one big block. One big block is this guy. And just fits M3 here. This is M3, just fits in here. And there's a pulley here. Consider that to be massless and friction pulleys. Massless and axial frictionless. Okay, like over here is frictionless, and then it's connected to this other mass. So the question is about what is this force if this guy neither moves up or down. And so there's a surface of contact here, and there's a could be potentially surface of contact here, has to be, and this side could be also surface of contact. So these are all frictionless surfaces. You might say there's another contact surface here, maybe it's on a floor. So that's also frictionless. So all 1, 2, 3, 4 contacts frictionless, and this is horizontal. Okay, so how do you figure this out? Maybe if you want to try this out and come back, you can pause the video. 1, 2, 3. So let's do this out. So because this is F is going to accelerate everybody. So if I just say the entire damn thing and I don't look inside, so that's just a entire damn thing being pulled with F. It must have some acceleration A, which I don't know, but this guy's mass is m1 plus m2 plus m3. So let's call this m total. So this is total mass like that. So you don't have to put coordinates or anything. This is just one direction. So A is F over mass total. Okay, so we got one equation. Now we need to figure out what A would be. Looking around, look at here. This thing is not going this way because this is not moving. So this one must be also fixed. Now M2 is static and M3 is static. So when to M2 you have a tension. Now this is a massless friction, so the tension here must be equal to the same as here. So this is tension, and this M2, and this must be going at acceleration A, because look at this, everything, the entire damn thing, every piece must be moving acceleration A. So M2 must be moving, otherwise it's going to slide, and there is no friction here, so that's the only force. So this is tension is M2A. So using these, let's call it M total A, right, like that. So this already A here is same as A here, so that's what I've written down over there is M total. And so if you do this M2, so this must be equal to that. So F over MT is equal to 1 over M2 tension. So we have a force equals to M total over M2 tension. So we made progress. The force is now we need to figure out tension. Well, we can try to examine this guy. That's what another tension is. So of course tension is that way because the massless frictionless pulley, right? And this guy is accelerating that way, A. So, but we need tension. So acceleration is opposite 90 degree tension. So we don't worry about that. So if you can see, these forces must be balanced in that direction. As the side, because there's a friction this way, this wall must be pushing. So there is a push here from that wall. There's a normal from the left wall. I bet their normal from the right wall, maybe like you could say this tiny amount that normal from the right wall. Net effect is like that. So you can write down left mass is M3A, but this no use because we just don't know those things. No use. Just trying to complete the discussion. So the vertical direction says T. This can't be the only force, otherwise it will accelerate. So this is M3G. So T is equal to M3G. So just put a number there. So this is equation number 3. This is 1, 2. Equation 1, 2. Give me that. So the F is just going to be M total over M2 times M3G. That's the answer. It's a pretty simple, cool problem. And that's it. So if you like this kind of problem I'm solving, please subscribe to this channel. And I will see you in the next video. Bye.